This conference will now be recorded.
Hi guys, today we'll talk about functions in Python. So, what is a function? Why do we need it? So, function is actually nothing but group of related statements put together to perform a specific task. So, suppose let's say that you are trying to print the elements of a list multiple times. In that case, instead of using the same code again and again, what you can do is you can create a function out of that and then you can start using that function. So basically it will help you to avoid any code repetition and it will make your code reusable. Also, it will help to make your code organized and manageable in the longer run. So this is the syntax of a function in Python. So you have to use def keyword and then the function name and then you have to pass the parameters that you wanted to use in your function. And then you have set of statements. So let's do one thing. Let's try to understand about these functions with the help of some examples. So I already have created a blank notebook. I'm going to use the same. So let's add a heading. My first Python function. So I will start with a very simple function. So def, let's say greet. So this is not going to do much. So this is just going to take the person name and then print it, right? So but one important point that you have to remember with respect to uh, defining any function is you have to mention the input and output details clearly. So what is the input? Input is nothing but the name of the person and output is nothing but display the display the given name, and also here you have to mention the purpose of this function. So let's say greets the given person, something like that. So basically just a simple example I'm just taking. The print hello and then let's say name. Let's run this. So here we have created the function to call this function name, and then pass the parameters. Let's say I'm giving some random name, and you can see the output, right? So this is how we can create the function. And whatever you're seeing here, this is called as document string, which will talk about the function name, what is the input and what is output. To see the document string, you have to use the function name dot underscore underscore doc underscore underscore. Hit enter. Now you can see the document string of that function as well. So whenever you create any function, it's a good practice to create the document string, especially in the projects. So we have created a simple function. We have also seen how to get the document string of that function. Now let's talk about return statement. So if you wanted to return some value from a function, that is where we can use return statement. Let's add a heading. So the problem statement is, suppose let's say that I wanted to find out the sum of the numbers in a given list and I wanted to return it. Let's say def get sum. It takes a list as an input, and then I will say sum of numbers equal to 0 for element in LST. Sum of numbers plus equal to, then you can take each and every element, and then finally you can return this sum of numbers variable. So here I have defined the function. Now I will create a list. Let's say a list of numbers 1, 2, 3, 4, 5. I wanted to find out the sum of these numbers. Hence, I can call this function called as getSum and then pass this list. Now you can see the output it is showing as 15. If you want, you can manually also verify this. 1 plus 2 plus 3 plus 4 plus 5, both are matching. So that's how you can actually use return statement to return something from a function, and then we have verified the same. So let's talk about scope and lifetime of the variables. I will add a heading. Scope and lifetime of the variables. Suppose if you take this variable called as sum of numbers, let me try to print it here. It is not accessible because the reason is this sum of the numbers is actually called as local variable and it is accessible only within that function. If you wanted to access it outside, it is not possible. It will throw an error. So basically, this variable sum of the numbers gets created for the first time whenever it is called, and once it is returned from the function, the value could be destroyed. That is why it is called as local variable. It is available only within that function, not outside. Now let's define one more variable somewhere above. Let's say number equal to 100, and I can access this number anywhere because this is kind of global. Local variable is available only within the function. Global variable is available throughout the function, throughout the notebook. So there are two types of functions: global, basically the built-in functions and user-defined functions. So let us look at these built-in functions. I will add a heading. So let's add a heading for built-in functions. So first I will talk about ABS. ABS is nothing but absolute value. Suppose if I take a number equal to 100, then if I try to print it, I'll get the value. Suppose I have another variable, let's say a equal to minus 40. If you try to print a, then it will give me minus 40. But if you try to use ABS, it will just give you only the value irrespective of the symbol. If I say ABS of a, it will give me this, right? So that's why it is called as ABS, absolute value. It won't worry about the symbol. Let's talk about all. As the name suggests, this all function will actually give you true or false. Let's say all of, let's say 1, 2, 3. As the values in this list are non-zero values, hence it is going to give me true. Even if you have one zero value, it will actually give you false. Not only zeros, same thing is applicable even if you have false as well, right? Then we have dir. So dir is actually used to get the list of all the built-in functions and variables that you can apply on a given object. Suppose I create a simple list 11, 22, 33. So this is a list right now. Type of a list, this is a list. To see the list of all the built-in variables and objects that built-in variables and then functions that you have, you apply dir. You get this. Let's talk about div mode. So div mode is actually used to get the quotient and then remainder. Div mode. So suppose let's say I have two numbers 9 and 2. 9 percentage 2 will get me the remainder. 9 divided by 2 will get me the quotient. I hope you are aware of what is remainder, what is quotient. I can get the same thing by using div mode. Div mode of 9 comma 2. You can see it's giving me the output as 4 comma 1. You can assign it a variable called as t. So here t will be a tuple. And we know how to access the elements in a tuple. T of 0 will get me the quotient, T of 1 will get me the remainder. So this div mode option, div mode function is very very handy, especially if you're working some numerical problem. Suppose finding out the sum of the numbers in a number, reversing a number, all those can be easily done by using div mode function. Let's talk about enumerate. I will add a heading. I'll define a list. I'll define a list of numbers. So this is the list of numbers. What you can do is you can actually loop through this list by using enumerate. Enumerate of LST. Then you can say print f index has value. So it should be 1 minute. Sorry for the interruption. I'm back. So now you can see that you should be able to figure out which index contains which value by using this enumerate. Now let's talk about filter. So filter is actually used to filter your data. So let me add a heading for filter. Then try to understand the syntax of filter. The syntax of filter goes this way. It takes two things as input. First one is nothing but the function call, and the second one is nothing but the list of values that we wanted to pass. So suppose, let's say that I wanted to figure out whether a number is a positive number or not. Let's say def is positive. It takes a number as an input. If that number is greater than 0, only then it is returned. Now let me define a list of numbers from -10 to +10. List of range of -10, let's say 11. So if you look at LST now, I have the numbers from -10 to +10. Now I wanted to get only the positive numbers from this. Then what I can do is I can say list of filter of. Observe the syntax. The first parameter is nothing but the function call, which nothing but is positive, and the second parameter is nothing but the list. So I'm passing this list. Now if you look at positives, you can see that you are getting only positive numbers. So now why did the name is filter? Because initially we had total 20 elements. After filtering out, we are left with only 10 elements. Now we'll talk about is instance. So is instance is actually going to tell you whether an object is instance of an object or not. Suppose I define a list. I define a list of numbers. Here LST is nothing but a list, right? Type of LST, that's a list. Now you can say is instance of LST comma list. This will give you true. Suppose if I create a tuple 1, 2, 3. Here T is nothing but a tuple. Now if you say is instance of T comma list, that will return you false because T is not a list, it is tuple. If I change this to tuple, that will give me true. That's with respect to is instance. Now let's talk about map. So map is actually used to change each and every value of a given list. So let's add a heading for map. Again, first understand the syntax of map. The syntax of map goes this way. First parameter is again a function call, and then the second parameter is nothing but the list of numbers that you wanted to play with. So let's say that I wanted to get the squares of the numbers. Let's say get square. It takes each and every number and then it will return the square of it. Now I will define a list of numbers from 1 to 10, list of range of 1, 11, so that I can have the numbers from 1 to 10. My goal is to find out the squares of all these numbers. Hence what I can do is I can say list of map of first parameter is nothing but the function call, which is nothing but get square, and then the second parameter is nothing but the list. So now if I print these squares, I should be able to see the squares of all the numbers from 1 to 10. Any questions till now, guys? I think we're good. No questions so far. We'll move on. So that's with respect to map. Now we'll talk about reduce. So let's go ahead and add the heading for reduce. So first I'm going to import reduce from func tools, import reduce. If you don't use this statement, then it will fail. So again, understand the syntax of reduce. Then you have reduce, and then you have your function call here, and then the list that you wanted to play with. Suppose I will define function to get the product. Get product. It will take two numbers x and y, and then it will return the product of those two numbers. Now I will define a list of numbers from 1 to 5. I have this list. Now what I want to do is I wanted to get the product of these numbers. So product equal to reduce of, again observe the syntax, first parameter is the function call, second parameter is nothing but the list. Now if you try to print this product, you can see it's getting the output as 120. If you want to verify, you can verify it manually also. You can see that both are matching. So these are some of the important built-in functions that you should be using, right? Again, a lot of times built-in functions may not be sufficient enough. Hence, you may have to create your own function. It is called as user-defined function. So let me talk more about the user-defined functions. So to get started with that, so first let me talk about something called as default function arguments. So what is default function arguments? And before that, let's try to understand why do we need it. I will add a heading. Why default function? Why default function arguments? So why do we need something called as default function arguments? What will happen if we don't use the default function arguments? So I'll take an example, very simple example. Def, let's say greet. It will take two parameters. It will take two parameters such as person name and then message. name, and then message. It's not going to do much, just printing it. Hello, then name, and then message. I've defined this very simple function. Now I'll call this function with two parameters, name and then message. Let's say Ram is the name, random name, and then let's say good morning. I can see the output, it's working pretty much fine. Because it's expecting two parameters and we are passing two parameters, everything is fine. Now what if I pass only one parameter? It will fail, right? Because it's expecting two parameters and we are passing only one parameter, and all these parameters are set from left to right. So whenever you're passing Sam, Sam will go to name, and we're not passing anything for message, and that is the reason for this failure. Now I will show you how to fix this problem. I will add a heading now. Default function arguments. Now what I'll do is I'll try to take this function. I'll slightly modify this. So here I'll set a default value for message. Let's say good morning, right? Now if I call this function again with the same values, so let's do one thing. Let's say this is good afternoon. So first I'm passing two parameters, Ram and then good morning. It is taking the same thing. Now if I pass only one parameter, this time it will not fail. It will take the default value of message. Right? If you pass two parameters, that will take the priority. Otherwise, whatever is the default value, the default value can be used by message. That's with respect to the default function arguments. We also have something called as arbitrary function arguments. But before that, I'll add a heading again. Why do we need something called as arbitrary function arguments? This is also called as var args. Why? Var args, variable number of arguments, or arbitrary function arguments. I will take the same example once again. I'll scroll up. So this function is actually expecting exactly two parameters, right? Now let's say if I pass exactly two parameters, things are fine, no problems. But even if I pass one parameter extra, it will fail, right? It is expecting only three, so expecting only two, we're passing three, it will fail, right? We will see how to solve this problem now. So now I'll add a heading for var args, variable number of arguments. This is also called as arbitrary function arguments. So the main syntax of arbitrary function arguments is, you will see this symbol called a star, right? So I'm not going to do much. I'm just going to take each and every name, and then I'm going to greet each and every name. For name in names, let's say print hello, then name. That's it. So now I'll not pass any parameters for the first time. It won't fail. Now I'll pass only one name. It will still work. So let me pass some cricketer names. It will still work. So basically, if you don't know the exact number of parameters, then that's where you have to use var args, variable number of arguments. Sometimes we don't know the parameters in advance. That is where we have to use arbitrary function arguments. Let's talk about recursive functions. So basically, a function calling itself is called as recursion, right? Now we will understand this with the help of an example. So first I'll add a heading. So recursive functions. I will define the problem statement. Find the factorial of a given number. Find the factorial of a given number. So I hope you remember what is a factorial is. So input is nothing but a number and output is nothing but 5 factorial. You generally represent factorial by using exclamation symbol. How to get 5 factorial? 5 into 4 into 3 into 2 into 1. You get 120. So this is what we need to do by using recursion. Let me define that function def recfact because we wanted to solve this problem by using recursion and the problem statement is factorial. Hence I have given the name as recfact. It takes a number as an input. It will check if that number is less than or equal to 1. If that is the case, then it will return 1. Else, call that function once again, but with the decremented value, that is number minus 1. So here, why am I calling it as recursion? Because you can see that this function is calling itself. That is why it is called as recursion. Let's run this function now. Recfact of 5, and you can see the output is showing as 120. But you have to be little careful when you use recursion because a lot of people don't take care about this terminating conditions such as number less than or equal to 1, something like that. Then you will see yourself in that stack overflow error. So please avoid that and be little careful when you use recursion. Otherwise it will be tough for you to debug, right? So that's with respect to the recursion. Now I will talk about anonymous functions or lambda functions. So first of all, what is the dictionary meaning of anonymous? So anonymous is something which doesn't have any name. So similarly, a function which doesn't have any name is called as anonymous function. So it is also called as lambda function. So with respect to the normal functions, we are going to use define that function by using def keyword and then we'll use it. But here in anonymous function, we don't need to do that. We can actually define the function body itself. That's where we call it as anonymous or lambda functions. So remembering the syntax of anonymous functions is important. The syntax goes this way. You have lambda keyword and then arguments and then you have to give the expression. Let's do that. So first I'll talk about filter with lambda. Filter with lambda. So, if you remember, we have filtered out the elements by using filter function, right? We will rewrite the same example now by using lambda. So again, remember the syntax of filter. I'll scroll up. This is the syntax of filter, right? Now, I wanted to define the same list once again. List of range of numbers from -10 to +10. I wanted to get the positives, right? So list of filter of. So the first parameter is nothing but the function call. So here we are not defining the function and then calling it. Instead, we can directly include the function body itself by using lambda. Lambda, arguments, and then expression. So here I'm going to use lambda, take each and every number, and then you have to just check whether that number is greater than 0 or not. Right? Only then you have to get that. Have a look here. We are getting only the positive numbers now. We are not defining the function. we are directly using the function body itself, and it doesn't have any name, hence it is called as anonymous or lambda function. So let's look at one more example. We'll try map with lambda. Map with lambda. Again, first we'll try to understand the syntax of map, then we will take it forward from there. So syntax of map is also similar to filter. So this is the syntax of map. Again, the problem statement was same. I wanted to get the squares of the numbers from 1 to 10 by using map. So first I will define that list. I have the numbers from 1 to 10. Now I wanted to get the squares of these numbers. This time I'm going to use list of map of. First parameter is nothing but the function call. I'm not going to create the function then call it. Instead, I'm going to use the function body itself directly here. So I'm going to use again lambda. Remember the syntax of lambda. This is the syntax. I'm going to follow the same. Lambda, take each and every number and then square it. And the second parameter is nothing but the list that we wanted to use. Now have a look at the squares. You can get that you're getting all the list of squares of the numbers from 1 to 10. Let's look at one more example. Reduce with lambda. Again, the first thing that you have to do is you have to import it from functools, import reduce. So I wanted to again find the products of the numbers from 1 to 5. Or let's say this time I wanted to get the sum of the numbers from 1 to 5. First, let me define this list. Range of 1, comma 6. I have a list with numbers 1 to 5. So now to get the sum, let's say get sum, let's say sum of numbers equal to, I'm going to use reduce. But this time I'm not going to create the function then use it. I'm going to use lambda and then pass those two numbers x comma y plus y. Then the list. The sum of the numbers 15. You can also verify it manually. 1 plus 2 plus 3 plus 4 plus 5. Now how is this reduce working internally? Let me give more details. So for the first time, I'll define the list also. This is the list that we are using, right? 1, 2, 3, 4, 5. For the first time, x is 1, y is 2. So we are getting x plus y, which is nothing but 1 plus 2, which is nothing but 3. Now for the second time, x will be nothing but the previous sum, which is nothing but 3. X will be 3, y will be the next element, which is nothing but 3 again from that list. X plus y is 3 plus 3, nothing but 6. Now for the third time, x is again from the previous sum, which is nothing but 6, and y is nothing but the next element in the list, which is nothing but 4. So x plus y is 6 plus 4, which is nothing but 10. For the fourth time, x is again from the previous sum, which is nothing but 10. Y is the next y is nothing but the next element in the list, which is nothing but 5. So x plus y is 10 plus 10 plus 5, which is nothing but 15. Now, do we have any more elements left in the list? We don't have. So whatever is the final value here, 15, the same will be printed, right? So that is how Reduce works. Any questions still here? Any questions, guys? So that's all you need to know about Python. So you don't need to be a master in Python. You need to know whatever is required to become a data engineer. That's what we have learned till now. So going forward from next session, it will be Spark, and every session is important from next session, right? Because in the interviews in the project, most of the times we'll be using Spark itself. Even in the interviews, 80% of the questions will come from Spark. So please don't miss any sessions from tomorrow onwards. Every session is very, very important. So before closing today's session, anybody have any questions? I will share this notebook with you. File, download as HTML. I will share the PPTs and then the notebook also with you. Keep it as reference and then practice. Right? So any questions before wrapping up? Okay, if no, then we will actually meet tomorrow. Every session is important from tomorrow, so just be prepared. We'll talk about Spark in depth. See you tomorrow then. Bye.